Hello class, just wanted to touch base with you guys and kind of supplement the videos that I posted yesterday. I noticed that they were of very poor quality, so I'm going to try to explain this on the board really quick. Now, I went over the statistics here. Hopefully you'll be able to see this. That's the test statistic. There's the degrees of freedom. There's my null hypothesis and my alternative hypothesis. I'm using an alpha level of 0.05, and then when I actually calculate my t-statistic using the data that I got from my Excel spreadsheet, which I will share with you again since it was very fuzzy on the video, I just wanted to show you really quick that I got a critical region, and I'll show you, since I hypothesized that the HO is no, or the null hypothesis, no change, but I hypothesized that mu1 was going to be less than mu2, and I actually got that result. So let me show you what that was. So I've got mu1, I have a distribution that looks like this, and it's going to be a t-distribution with a mean of 74. So 74 is going to be my mean. Now I hypothesized over here that on my alternative hypothesis that mu1 was going to be smaller than mu2. So mu2 is 87. So now I've got another distribution with a mean of 87. So that's kind of what they look like. So now my test statistic will determine whether or not that are they significantly different from each other based on an alpha level of 0.05. So the first thing I got to do is find my critical region. So I'm going to do that. And how I do that is I'm going to look up in a table of critical values for a t-test. Now, when I do this, I will look for 18 degrees of freedom and an alpha level of 0.05. And when I line those up, I'm going to find that my critical region is a score or a value of 1.734. So I'm going to move back over here into my original distribution. I'm going to find a value of 1.734 standard deviations away from the mean of 74. So now I can shade this area in, and if the mean of sample 2, which is 87, falls in this critical region here beyond 1.734, then I know that I have a statistically significant difference in the means. So I can change that 87 into a t-score, and my t-score will be a greater t-score than 1.734, and we're going to do that. And when I actually did my statistics, I found that my value is actually a 2.228 standard deviations away from the mean. So basically, my alternative hypothesis is true that, I have statistically significant results. And so basically what I would do to change this up is my critical value or critical region would be a negative score, since I'm going to be looking at the negative side of my distribution of my second sample. So I'll be looking at this side, and I'm going to say that 74 falls in the critical region, and it falls beyond negative 1.734, I believe it was what it was. So this would be my critical area, and this score of 74, which yielded a t-score of negative 2.28, falls well into this critical region, so I can say this mean of 74 is significantly lower than the mean of 87 here. And so that matches right up with my alternative hypothesis. Now let me take you to my computer, and I'm going to run you through the Excel. So I want you to get a clear picture of the numbers that I'm using, and I want you to kind of practice these numbers as well. And I'll take you through this, and we'll just start from scratch, and we'll just erase all these numbers, and I'll show you how to get them. And like I say, I would suggest that you practice. You can practice these numbers and make sure that you're getting the same numbers that I am. That will help you out tremendously, and it makes things a lot easier too, like I say. So the first thing I'm going to do is I'm going to fill in these boxes. So my data, this is sample 1, this is mean 1, and this is mean 2. And what I hypothesized was that the class 2, mean 2, after I average everything, is going to be significantly higher than this class 1. I used an intervention of supplemental videos here to raise final exam scores. So these are the final exam scores of 10 students in class 1 who didn't receive the supplemental videos. This is class 2. This is 10 students who were picked at random who received supplemental videos, and these are their final exam scores. So the first thing I'm going to do is I'm going to find the average. So I'm going to command Excel to find the average, and I'm going to put an equal sign, and then I'm going to spell out average, A-V-E-R-A-G-E, and then I'm going to put a parenthesis, and then I'm going to highlight my data. I'm going to close the parentheses, and I'm going to hit enter. So that should give me my mean or my average for class 1. Now, nifty little trick here is to just put the mouse pointer back over 74, the mean, and when your mouse pointer turns into a plus like that, just use your left mouse button and then drag that plus sign over to the next class, and it will automatically calculate the mean. So I'm going to do the same thing for standard deviation. So I'm going to come over here, highlight my box, and I'm going to command Excel to find the standard deviation. So I'm going to go ahead and type in STDEV for standard deviation, and I find that, and I'm going to go ahead and put a parenthesis down and highlight my data again. Okay, I got that. Whoops, got too much there. Okay, that, and then I'm going to close my parenthesis, and I'm going to try to calculate what that is. It is 16 point, and what I did is I just hit enter. Now what I'm going to do is I'm going to highlight that box again. I'm going to wait till my mouse pointer turns into a plus sign, and I'm going to drag it over so it will calculate the standard deviation there. Now remember, the variance is the standard deviation squared. So I'm going to come down here, highlight the variance box, and I'm just going to go ahead and command Excel to, and what I'm going to do here is I'm going to come back up here, highlight the standard deviation, B13, and I'm going to command it to find, I'm just going to command it to square it. So I'm going to come up here to my number 6, and there's a little symbol that's called the hat. So I'm going to use the hat above 6, and then I'm going to use a 2 to square it, and then I'm going to hit enter, and it will give me my variance. I'm going to go ahead and highlight the box, pull my mouse pointer till it finds the plus sign, and I'm going to pull it over, and it will calculate my variance for class 2. Now I'm going to find n. Now n is going to be, I'm just going to tell Excel to count. So I'm going to put the equal sign in and just say count, and then I'm going to use a parenthesis, and then the value is going to be my data, and I'm going to put another parenthesis, and then I'm going to hit enter, and it gives me a value of 10, which is how many scores I have. I'm going to highlight the box again, pull my plus sign, drag it over to class 2, and it will calculate that for me. Now all I have left is a t-test. So I'm just going to put it, put in the word t-test. So equal t-test, T-E-S-T, and now I can just determine what I need to do for the t-test. So I'm going to put a parenthesis, and it's going to ask for array 1. So I'm going to go ahead and highlight my data, all 10 data points, and I'm going to put a comma because I need an array 2. It's commanding me to do that. So put a comma, and then I'm going to come up here and highlight my second set of data in class 2. I'm going to put a comma, and then it's going to ask me for 1 or 2 tails. I'm using a one-tailed test because I'm saying that there's a statistically significant difference between the two means, and I say that it's going to be less than the mean of class 2. So I'm going to use a one-tail. So I use one-tailed test. Whoops, sorry about that. So one-tailed test is a 1. And then I'll put a comma, and that's going to ask me for 2 samples equal variance, paired sample, or 2 samples of unequal variance. Since I've got equal n's, I'm going to go ahead and use a 2 sample independent variance t-test. So it would be 2. So I'll come back up here and type the word number 2 in for a 2 sample equal variance t-test. I'm going to close my parentheses, hit enter, and it will calculate not the t value, but it will calculate a p value. And from what we learned already, that p is going to be the probability for making a type 1 error. So when we take all of these values, I can then come over to my actual test statistic here, and I can plug in my mean 1, my mean 2, my variance for sample 1, my variance for sample 2. I know that my n for sample 1 is 10, my n for sample 2 is 10. So what I've done, I've just taken all those values and plugged them into my formula. I've calculated that, and I get a value of, a t-value of negative 2.28, which tells me that it is significantly different. Back to my alternative hypothesis, I'm saying that the mean of sample 1 is going to be statistically lower, less than the mean of sample 2. And when I take that up here, I find my critical area. I know that. But when I go back to my t-test on Excel, what it shows me is the p-value, which is a probability for making a type 1 error, and that is 0.019. I set my alpha level at 0.05. So the p-value is lower or less than 0.05. Therefore, I can reject the null hypothesis. I hope this video helps, and hopefully it clears things up so you can practice this. I will give you some homework in a few days after I cover some other statistical tests, and hopefully this will be much easier for you than calculating everything out by hand. All right, have a great weekend, and I will see, I'll do another video soon. Thanks, bye.